As many of you may know, AI in gaming is a very divisive subject. Some people say it's nothing but slop and theft. Others say it will revolutionize video games. I used to be closer to that second group. You see demos of NPCs powered by LLMs, AI-generated dialogue, procedural storytelling, and it makes it look like you can just drop a model into a game engine and everything works. Coming from a background in AI, I never really believed it was that simple. But I did think that if you integrated those systems in the right way, they could enable some really interesting things. And to some extent, I still believe that. But like a lot of things in engineering, and in life in general, there's a catch. Actually, several. A while back, I found a project that integrated LibTorch into Unreal Engine. It started as someone's capstone project, and I began extending and improving it. This project eventually became LibTorch-UE. Working on it gave me a much closer look at what it actually takes to run modern AI systems inside a game engine. And the reality turned out to be a lot messier than the demos make it look. In this video, I'm going to explain why I stopped developing LibTorch-UE, the technical problems I ran into, and why integrating modern AI into game engines is much harder than most people expect. Before getting into the technical issues, I should quickly explain what LibTorch-UE actually is. The repository integrates LibTorch, which is the C++ backend of PyTorch, directly into Unreal Engine. In this video, I'm going to walk through the main reasons I stopped developing it. Some of the problems are specific to the repository itself, but others are much broader issues that show up whenever you try to integrate modern AI systems directly into a game engine. And if people are interested, I might make a follow-up video about the state of AI in game development more generally, because many of the challenges I ran into here show up across multiple engines. I actually stopped actively developing LibTorch-UE quite a while ago. There were two main reasons for that. The first was technical limitations that made the project increasingly difficult to maintain and extend. The second reason is much simpler. Life got busy, and I ended up focusing on other projects. I will be introducing the project that I'm working on now at the end of the video. Technically, the repository could probably be brought up to work with modern versions of Unreal and PyTorch. But after looking at the effort involved, the project's limitations, and the direction the AI ecosystem has gone, I don't think it's really worth continuing development in its current form. Before going deeper, let's quickly define a term that comes up a lot when talking about machine learning: inference. Inference just means using a trained AI model to make predictions on new data. For example, when you type a message into ChatGPT and it generates a response, that's inference. The model was trained beforehand and is now just running the train weights to produce outputs. The main problem is that LibTorch isn't really ideal for running inference with modern large language models. Most modern LLMs are developed and run in the Python PyTorch ecosystem. Solutions for running the models in C++ are available, such as Llama CPP, but those do not solve all the issues. While LibTorch is technically the C++ version of PyTorch, porting models from Python PyTorch into LibTorch is not always straightforward. When I originally built LibTorch-UE, I tried to load models using the typical workflow. You export the model from PyTorch and then load it in C++ using torch-git-load. This did not work properly. I ran into the same issues as others before me. An issue with memory allocation that would crash Unreal when using the forward method. To get around this, I had to re-implement the Llama architecture in LibTorch to be able to load the pre-trained weights in Unreal. This allowed me to manually load the pre-trained weights using an input archive and run the model inside Unreal. But obviously, this is not a scalable approach. Every time a new architecture appears, which happens constantly in the AI world, you would have to re-implement the entire model architecture in C++ just to run it in Unreal. Eventually, I did figure out why torch.jit load wasn't working properly. The problem was related to memory allocation. Unreal uses its own memory allocator. In many builds, it uses mmalloc instead of the default C++ allocator. LibTorch uses various allocators. LibTorch assumes memory was created using the same system it uses internally. On most systems, it defaults to POSIX memline from libc. Unreal would allocate C++ objects using its allocator. Those objects would then get passed into the LibTorch DLL, and LibTorch would eventually try to free that memory. But LibTorch assumes that the memory was allocated using its allocator, so when it tried to deallocate it, things would break. Later on, I figured out what the real fix should have been. The issue wasn't LibTorch itself, it was the allocator boundary between Unreal and the DLL. The correct solution is to compile a separate DLL outside of Unreal with a C wrapper. The DLL handles all LibTorch interactions internally, so LibTorch allocates and frees its own memory consistently. Unreal then just calls those functions through the C interface. If you are interested in a tutorial on this, please leave a comment. Even with that fix though, there is still a bigger issue. Modern AI models are complex and evolve extremely fast. The models generally can't be traced and converted to Torch script without additional work. It is possible, but generally requires knowledge of PyTorch to achieve. Again, if you are interested in a tutorial on this, please leave a comment. Even if the software side worked perfectly, there's another problem: hardware. Running a game and machine learning model on the same device isn't ideal. Unreal Engine already consumes a significant amount of GPU resources. Now imagine trying to run a neural network on top of that. Your VRAM gets eaten up very quickly. This isn't just a LibTorch-UE problem either. Other projects trying to do similar things, like Llama CPP and Onyx integrations with Unreal, run into the exact same limitation. In practice, you're usually stuck running very small models, and even those can become expensive if your game already pushes the GPU hard. For training, the situation gets even worse. For small models, you can sometimes train directly on the user's or developer's device. I mentioned the developer in this scenario for situations like training a smart NPC, where the model would be trained by the developer and a pre-trained model would be released for the users. But anything more computationally demanding would require remote training infrastructure, and servers often don't even have graphics enabled, which creates another layer of complexity when integrating with game engines. There's also a more practical limitation: developer knowledge. Machine learning is still a specialized field. Most game developers don't have a background in it. While it's easy to plug in something simple like AI dialogue, NPC responses, and text generation, building custom ML systems inside a game is much harder. You generally need to understand model architectures, training pipelines, inference optimization, memory constraints, and more. And on top of that, my repository didn't help much. The codebase is overcomplicated and poorly documented, which makes it harder for developers to adopt. Even if the tech worked perfectly, the learning curve was still pretty steep. With these limitations in mind, it is still possible to integrate AI in your game, but it is messy. If you are interested, please leave a comment about how you want to use AI in your game. I could then make a follow-up video on if and how those aspirations could be achieved. What I'm working on now is training a model using a new strategy. Instead of working to create bigger models, I'm exploring techniques to make small models better. I'm currently working on training a model similarly to how a child learns. I will be making a video about that in the future. If you are interested, the link to the project is in the description. Thank you for watching.